Hello again, guys. I want to start by reminding you that if you are having any issues with 4.1 or 4.2, to please let me know and I will try to get you help any way I can. Today we're going to dive into solving systems using elimination, which is similar to what we were working on in class, except for now we look at ways to make things easier, actually. So take a second, read this, make sure you understand that, and I'm going to jump ahead and go down below here. So here we're going to look at how we can kind of deal with these equations. Then we'll look at some examples that really help solidify these ideas. So if you were talking about two different equations that share the same variables and two of them have opposite values, we can actually add the equations together. And when we add these together, the variables combine, so therefore opposite values are additive inverses, which means they add to 0. So if we have 5x plus 3x, we then get 8x plus that 0 equal, when we sum a positive 40 or positive 48 and a negative 32, we get 16, because that's essentially like 48 minus 32. So then we get 8x is 16, and from there hopefully you can quickly see that, sorry, I'm thinking ahead, that x will be 2 after the division by the 8. So take a second, pause the video, and try and solve b on your own. Alright, so to talk through b, the think over here is asking you which variable should you eliminate. So hopefully when you think about that, you say the ones that are opposing each other or additive inverses. So here that'll be my negative 3x, my positive 3x. So then I add my other values, and those combine to give me a negative 7y. Then I add my constants on this side. Those give me 14. So when we divide by negative 7 on both sides, a positive and a negative in division give us a negative, so we get that y equals negative 2. Alright, this situation is where it starts to really make sense for some people. So if we are washing 2 cars and 3 trucks, and that takes 130 minutes, and then we're also washing 2 cars and 5 trucks, and that's going to take 190 minutes. See here that we have two of the same variables that happen. Maybe this is data if you own a car wash or something like that, that you're trying to solve how long it takes to wash these certain types of vehicles. So go ahead and set up what you think would be equations that could represent both of them. I'm going to change my colors here because that ended up the same, and we'll be right back. Alright, so hopefully you set up equations similar to this with the one minor tweak that I wrote down one of the wrong minutes values here. So then if I stack my two equations here, my first situation had 2 cars. I'm going to use p for pickup since I don't really like using the variable t. And that took 130 minutes, and then 2 cars and 5 pickups takes 190 minutes. Now it'd actually be better if this bottom equation was on top for our subtraction, but I can think of it like that. I'm going to subtract this entire equation down here from on top. Because that is what we're discussing now through subtracting, sometimes, a lot of times, easier than through addition. So what we see is that a negative in variables, a negative 2p is equal to a negative 60. But what we really know that means is that 2p, 2 pickup trucks, take 60 minutes. So we can do the division to find out that that means 1 pickup truck takes 30 minutes. Now that we know that, we can plug back into either equation and figure out how long it takes to wash a car. So figure that out. So when I plug into that equation, I can then say that 2 cars plus 3 times the amount of time it takes to wash a pickup, which is my 30 minutes, equals 130 minutes. I know this will be 90, so that'll be 2c plus 90 equals 130, and then I can subtract my 90 from both sides, which leaves me with 2 cars takes 40 minutes, so that will tell me that 1 car is equal to 20 minutes. And then we of course want to have our label of minutes. So that is one of the practical ways that we can use systems of equations to solve problems. So here we're going to get into a method where we're going to use one of those methods after we use a multiplication on each side. So go ahead and read this, make sure this makes sense, and then I'll pick back up down on the next problem. So now problem 3 here is asking about solving a system by multiplying one of these equations. So what we're looking for is 2 of these where I can multiply, and I can multiply by whatever on top and whatever on bottom can be 2 different values, but I have to multiply by the entire equation. So think to yourself, what could I multiply into these equations, 2 different numbers, top, bottom, or if I could just multiply one equation by one number, that'd be easier to get them to be opposite variable values. So could we do something with a 5x and the 3x? Could we do something with the negative 2y and the positive 6y? And what? Go ahead and try that on your own. Pause the video and take a second. So if I set up these 2 equations, I think it'd be easier to multiply this equation because if I look at the negative 2y and the positive 6y, all I need to do is multiply this equation by 3, and that will make the y's cancel each other out. So when I follow that multiplication through, this becomes negative 15x minus 6y equal to, because we have to multiply every single thing in there by 3, this is equal to 18 then. So then if I can combine these 2 equations, I can get the y's to cancel out and the x's to solve. So go ahead and try that. So if I combine those together then, I can get a negative 12x. These combine to 0, and then that's equal to, when these add up, they become 24. And then to solve, you can see that all we need to do is divide by a negative 12 on both sides, which gives my solution of negative 2. So if I want to check this, I can go ahead and plug the value for x in and say that 3 times the negative 2 for the x plus 6y equals 6. Well, the 3 times negative 2 will give me a negative 6, which then, to get rid of my negative 6 from my left side, I would just add 6 to both sides, giving me that 6y is equal to 12. And once I see that 6y is equal to 12, I know that y is in fact equal to 2. So now that we know that x is negative 2 and y is positive 2, we can plug in both of them to one of the original equations and check that they work. So go ahead, take your x and your y, plug them in to one of the original equations right up here, and check that it does in fact equal 6. Now go ahead, pause the video, and try 5 and 6. Try both of them. You need to multiply at least one of the equations by something to get rid of one of the variables to then solve for the second. So pause the video now. Alright, so what we want to do for 5 is I see that the y's are pretty easy to get opposites because we have a positive 1y and a negative 2y. I can just multiply the top equation by 2, which when I do that gives me this equation, 6x plus 2y equals 10. So then go ahead and combine these and work towards the solution. So now when I combine these together, I see that 8x is equal to 8, and then by simple division on both sides, I see that x is equal to 1. Now take that, plug it into either of these equations to find out what y is. When we plug in the 1 to the top equation, I see that it's 3 times 1 plus y equals 5, so 3 plus something equals 5, which means that y must in fact be 2. If you have not done so yet, go ahead and solve for 6. Right after we write, because we need to get in this habit and I need to make sure that we're doing this, write the solution as the point. So our point 1, 2, that is the solution of these equations. Go ahead, try 6. Pause the video now. Alright, so the first thing that we should clue in on for 6 is that the 6x and the negative 3x could easily become opposites of each other if all I do is multiply by 2 in my bottom equation. So carry out that multiplication and see what you get. So from our multiplication we get a negative 6x plus 6y equals negative 12. Then we write our other equation down below it, and we want to add these since they're opposites. So this will give me a 0 plus a 4y, sorry, this should be a y. And when I add this, I get a positive 30. So now I have 4y equals a positive 30. I have made another mistake. So what I actually have is 10y equal to 30. So when I solve that by dividing by 10 on both sides, if my pen will pick up, I get that y is equal to 3. If you don't have x yet, plug that in and solve for your x. So if I plug the y being 3 into my second equation up here, which I think was my original first equation, I will see that I get 6x plus 12 is equal to 42, which then I can subtract 42, or subtract 12 from both sides and get that 6x is equal to 30. And when I would do that division on both sides, I would see that x would then be equal to 5. So there we have it, our solution point of 5, 3. Perfect. So now is what I keep alluding to with where we multiply both equations. So if I look at the x's here, I could think about the least common multiple being a 12. If I look at the y's here, though, I could think about the least common multiple being a 6. Now, if you think, why might I choose my y's to make the same value, is because actually they're opposites, because one's positive and one is negative. So if I actually multiply and make those 6, then I can just add the equations together to be able to eliminate. So let's go ahead and try to carry out that process. So if I analyzed the two equations that we started with and looked to match those y's, I needed to multiply the top equation by 2 and the bottom equation by 3. So now I get that 8x plus 6y is equal to negative 19. And in the bottom equation, I get that 9x minus 6y is equal to a negative 30. And again, I only get one shot to do this, so I have made a mistake. That negative 19, pat yourself on the back if you caught that, should be a negative 38. So now we want to combine these, and since the y's will just cancel each other out, go ahead and do that addition on your own. Pause the video, go ahead and finish solving for x, and if you're bold, go ahead and plug it back in and find your y. So when you combine this, you get 17x is equal to negative 68, which actually, if we divide not a negative, a positive 17, we end up with an x value of negative 4 for your answer. So plug that 4 in to find your y, and then you will have your solution point, and then plug that back in to check that it works for the whole thing. Pause the video. It doesn't really matter which one we decide to choose, so I go ahead and put my x equal to negative 4 inside the equation right here, and then I'm going to scroll down so I have a little bit more space to solve. So go ahead and do the math, solve for your y if you have. And what I get then when I follow the solution through is that y is equal to negative 1. These should both have a negative sign in front of them. If I make a short line, my pad deletes it for some reason. You may have noticed that. Alright, so if we move on, solve both of these on your own, and I will be back so you can check it. We were running out of time, so sorry that I did not check this one, but solve for the solution point on both 7 and 8. For the sake of time, here are your solution points. If you did not get those correct, check something in your math. Pause the video and study this flow chart so you can understand what we're looking for if we talk about a system of equations having one, none, or infinitely many solutions. So if we're trying to solve this by elimination, we try to get our variables to be equal. So I multiply the top equation by 2, and I get 10x minus 6y equals 20, and then I have 10x plus 6y equals 20 on the bottom. So what I end up getting is that 20x is equal to 40. So we see x equals 2, and we have one solution. So in the equations on the right, in number 10, we multiply by 2 in the top equation, and then these actually cancel out to be 0 plus 0 equals 0. So if this is completely true all the time and there are no variables, nothing solved, no solution point, then this has infinitely many solutions, which means that the slopes are identical. And they have the same y-intersect point. So we are just about out of time on this video. We may pick up with another one to explain this, or we may get this in class. Do your homework. Have a great day.